When NASA unveiled the extensive image gallery of 3 Atlas, I found myself engrossed in the data for several minutes, utterly captivated by the depth of its implications. For the first time in recorded history, 15 spacecraft itself, a mix of Mars orbiters, deep space probes, Hubble, Webb, and the Lucy mission focused their cameras on a singular interstellar visitor simultaneously. Throughout my scientific journey, I've encountered countless remarkable phenomena, yet I've never come across a dataset this vast or intricate. This is true for Oumuamua, Boris, or any comet, asteroid, or fleeting celestial entity. NASA accomplished something truly remarkable. They orchestrated the most extensive, multi-mission observational campaign ever on an object from another star. The most astonishing discovery is that every image captured from different angles unveils something unique. There are changes in brightness, structural configuration, tail orientation, coma shape, morphology, halo, dynamics, and thermal characteristics. It's as if 3 Atlas isn't merely a single comet, but an evolving enigma that reveals a new element of its identity with each observing spacecraft. From a scientific standpoint, this is the most exhilarating type of mystery. Activating 1 or 2 spacecraft to monitor a passing object is standard protocol for NASA. However, dedicating resources from 15 missions, including Mars rovers, infrared scouts, solar observatories, heliophysics satellites, and deep space explorers sends a strong message. It indicates that NASA considers this object not merely interesting, but potentially groundbreaking. The missions involved included high-resolution morphology from the Hubble Space Telescope, infrared chemistry data from the James Webb Space Telescope, JWST, thermal signatures from SphereX, ultraviolet hydrogen halo detection by MAVEN, high-resolution dust envelope imaging from Mars Reconnaissance Orbiter, MRO, solar interaction imaging from punch surface observations from the Perseverance rover, deep space angle measurements and trajectory drift analysis from the Lucy spacecraft, with near-sun imagery from SOHO and Parker Solar Probe, as well as observations from Europa Clipper. This interstellar visitor receives a level of attention usually accorded to major specialized planetary missions. Why? Because 3I Atlas exhibits non-standard physics, or at the very least demonstrates behavior that significantly challenges the models we have in place for comets originating from our solar system. Local comets tend to behave predictably, with their morphology changing gradually within well-established patterns. 3I Atlas behaves otherwise. Its tail direction fluctuates. Its coma size varies erratically. The brightness of its nucleus changes unexpectedly, and its dust envelope appears thicker and more symmetrical than what we observe in local comets. The more detailed the examination, the stranger this object seems. Upon first reviewing the Hubble Space Telescope image, I quickly recognized the cause of the scientific community's unease. Rather than the typical triangular tail associated with a comet that is actively shedding material in sunlight, it appeared as a smooth, teardrop-shaped, bluish cocoon, elegantly symmetrical around a bright core. This image seemed far more reminiscent of a protective casing than a chaotic plume. While natural comets release material in irregular, volatile bursts, 3 Atlas seemed to be emitting dust in a remarkably uniform, controlled fashion, as though the outgassing were being carefully managed beneath a hardened, resilient surface. This singular image highlighted several crucial aspects. The nucleus remains whole despite being near Mars's distance, the dust is not being ejected as expected by solar radiation, and the outgassing process is unusually stable compared to that of typical comets. The cocoon strongly hints at deep subsurface volatiles rather than simply shallow ice. The overall color suggests unusual mineral compositions or grain sizes. In conclusion, this is undoubtedly not a fragile snowball, but instead a robust, resilient object formed by environmental conditions we're yet to fully grasp. Many of my colleagues were profoundly startled by the MAVEN ultraviolet images. Instead of a small, compact coma, a cloud of gas and dust around the nucleus, a massive UV hydrogen halo was detected, far exceeding any predictions of existing models. Such a colossal halo signifies one crucial factor: extensive water dissociation. The hydrogen atoms result from ultraviolet light breaking apart water molecules. Thus, MAVEN's findings suggest that 3I Atlas isn't merely leaking water, it is outgassing it in substantial volumes, despite being relatively distant from the sun. This raises a perplexing question that has nagged scientists since the beginning. Why is 3I Atlas sublimating water at such a distance, where most comets within our system remain entirely frozen? Three main theories emerge: internal heat sources, supervolatile chemistry, or a thick, insulating crust that permits efficient, controlled venting. Each hypothesis is scientifically intriguing and suggests an origin and composition fundamentally distinct from the comets we currently understand. The high-resolution image from the Mars Reconnaissance Orbiter MRO was another eye-opener. It portrayed 3I Atlas as a white semicircle rather than a mere point-like object with a translucent veil of dust surrounding it, displaying unexpected brightness and symmetry. This data from MRO leads to two key conclusions. The nucleus appears to be of considerable physical size, likely several kilometers wide, and the dust envelope is significantly thicker on one side, indicating anisotropic uneven heating, which is highly atypical. Most comets exhibit distinct tails. In this case, an orb or shell seems to form. The image even included a scale bar, confirming it was captured 890 miles above the comet. Remarkably, even from that great distance, the dust cloud was clearly observable. This suggests it's a substantial object, not necessarily in mass, but in the sheer volume of surrounding material. The Punch spacecraft registered a faint tail extending sideways, noticeably not in the direction of the sun. This observation is remarkable, as comet tails generally point directly opposite the sun due to continuous solar wind pressure. Punch, however, indicates the tail's angle deviates entirely from expected forces. There are two central scientific interpretations: local solar wind variability as a shifting environmental force, or non-gravitational acceleration due to asymmetric jets, the propulsion mechanism previously discussed. Both explanations are plausible, yet the second one carries significant implications as it closely mirrors the unexplained acceleration seen with Oumuamua. While this observation does not confirm artificial propulsion, it undeniably points to unfamiliar physics at play. Nature often catches us off guard, and this fact alone justifies continued rigorous monitoring. The Psyche spacecraft tracked 3I Atlas for 8 hours, revealing something subtle yet crucial. The path of 3I Atlas across the starfield exhibited slight irregularities, tiny deviations that were nearly imperceptible but measurably distinct. This type of high-precision data enables astronomers to differentiate definitively between gravitational effects and other influencing forces. Every detected interstellar object thus far has shown some degree of trajectory variation, and 3I Atlas is no exception. This does not inherently imply intelligence, but signifies complexity, which is always meritorious of dedicated inquiry. The Spherix mission made an unexpected observation of a bright thermal core, suggesting that the interior of 3I Atlas might be significantly warmer than presumed, potentially due to radiogenic heating, trapped pressurized gases, or simply a dark surface adept at absorbing sunlight. However, when viewed alongside MAVEN's extensive halo readings, the thermal signature implies a layered structure, perhaps with a thick crust, encompassing liquid or semi-liquid areas. Again, this object does not behave like a simple, homogeneous comet. Lucy monitored 3I Atlas from a vantage point nearly opposite the Earth, yet the object's brightness from both viewing angles appeared remarkably consistent. This suggests either a nucleus with high albedo, capable of reflecting substantial light, or dust grains with strong backscatter properties. Regardless of which factor applies, this behavior is unusual. SOHO barely managed to identify 3I Atlas, perceiving it only as a faint yellowish dot, nearly obscured by background noise. This observation contradicts its bright appearance in different wavelengths. Overall, the combined imagery implies that the object reflects poorly in the visible spectrum but emits strongly in infrared and UV, hinting at an unconventional, non-standard surface composition. This offers a vital clue to its ultimate origin. When these images are synthesized, a clear pattern begins to take shape. Hubble displays a teardrop cocoon, MAVEN uncovers a vast hydrogen halo, MRO depicts a semicircle, Punch captures an angled tail, Psyche reveals subtle path deviations, Spherix detects a hot core, Webb identifies specific chemical offsets. SOHO records faint visible scattering. Perseverance observes subtle dust. Lucy perceives deep space brightness. And Stereo records vertical stripes. Each instrument faces a challenge from Atlas. Each specialized tool uncovers a different facet of the same object, reminiscent of the classic tale of blindfolded observers, each touching a unique part of an elephant. The only scientific conclusion, consistent with the amassed data, is that 3I Atlas is not a typical comet. It represents an interstellar artifact of natural processes beyond our current comprehension. As I reflect on the entire gallery, I'm reminded of the fundamental reason for the existence of science. For billions of years, this object drifted unnoticed in the tranquil darkness among the stars. Then, for a brief moment in cosmic history, it came close enough for humanity to observe it, measure it, question it, and learn from it. NASA's image gallery is far more than just a compilation of images. It embodies our collective endeavor to decipher a complex message conveyed through dust, starlight, and ice, a message sent long before humans even evolved. Whether 3 Atlas ultimately reveals the secrets of planetary collisions, fragmented exomoons, or simply complex chemistry, one thing is certain. We are destined to learn something profound and novel about our universe. For any scientist, that is the most remarkable gift that an interstellar visitor can provide.